Example 7. Given f of x is equal to 1 over x minus 1, find f inverse. Give the domain and range of both f and f inverse. All right, so example 7 is very similar to examples 4, 5, and 6. The only difference here is we're not graphing. Okay, so let's look at this. I've got some room to work, and then if you scroll down, there's a spot to put in the domain and range information. Okay, I am going to start by working with f here. Okay, I can find the domain of f. Okay, I'm going to do that before I find the inverse. Okay, this is a rational function. It's a fraction. So remember, to find the domain of a fraction, you need to find the bad spots. The bad spots are the x values that you plug in and they cause division by 0. So I'm going to go ahead and write, to find the domain of f, what I'm going to do is take the bottom and set it equal to 0 to get the bad spots. Okay, so if you solve this, just add 1 to both sides, you're going to get that your bad spot is x equals 1. Okay, and you can eyeball and check that. If you plug in x equals 1, you're going to divide by 0, and that's bad. Okay, so the domain of f is going to be all real numbers except x equals 1. Okay, in interval notation, okay, we're going to write it this way, and you can draw out your number line if you still need to do that. Okay, it's all real numbers except for 1. Okay, as soon as you write this down, okay, you know the domain of f is going to be the same thing as the range of f inverse. So I'm going to go ahead and write the range, and I'll use a different color here for the f inverse stuff. The range of f inverse is going to be the same thing. Okay, we haven't even found f inverse yet. Okay, but we know what its range is going to be. All right. So now I'm going to come up here, okay, and I'm going to start working on trying to find the inverse function. Okay, so my first step is going to be to replace f of x with y. So I'm going to get y is equal to 1 over x minus 1. Okay, then the next thing I need to do is switch x and y. Okay, so I'm going to get x equals 1 over y minus 1. And you need to solve this for y. Okay, so you might be like, well, what in the world do I do? Okay, well, let me show you. Okay, so I'm going to come up here. Okay, I am going to make the left side a fraction. Okay, you can make anything a fraction by putting it over 1. So I'm going to get x over 1 is equal to 1 over y minus 1. Okay, and here is the trick. Anytime you have one fraction equal to another, you can cross multiply. That means this times this has to equal this times this. Okay, you can only do that when you have one fraction equal to another. So this is going to tell us that x times the quantity y minus 1, you've got to use parentheses there. Okay, this times this is equal to this times that. Okay, so 1 times 1. Okay, that's the result of cross multiplying. X times the quantity y minus 1 has to equal 1 times 1. Okay, all right, so then you've got to solve this for y. You're probably like, well, what do I do next? Okay, your first instinct might be to multiply or distribute on the left, and you're right. Okay, you may not see where that's going, but that's the correct thing to do. Okay, we're going to distribute on the left. We're going to get x times y minus x, okay, that's what you get if you distribute, okay, is equal to 1 times 1, which is 1. Okay, again, where do you go? Okay, you're solving for y. Okay, only this piece has a y. Okay, put everything that has a y on the left, and everything that doesn't have a y, put it on the right. Okay, so I'm going to move the x over because it does not have a y. So I'm going to add x to both sides. Okay, I'm going to get x times y is equal to x plus 1. Okay, and then I'm almost there. If I want y, okay, y is being multiplied by x, so to undo that, I'm going to divide both sides by x. Okay, so on the left side, x divided by x is going to, those are going to cancel and leave you with y equals x plus 1 over x. Okay, you can leave it like this, or you can break it up into x divided by x plus 1 over x. Okay, it's up to you. It's also correct to have the answer 1 plus 1 over x. Okay, and you're done. You have solved it for y. Okay, y is by itself on the left side. On the right side, you don't have any y's. So that's how you know that you're done. Okay, so I'm going to go ahead and write the answer right here. Okay, f inverse of x, there's two ways you can write it. Either one is acceptable. You can write x plus 1 all over x. That's the same thing as 1 plus 1 over x. Okay, this is the inverse function. Okay, all right, so let me box this. Okay, now that we have this, okay, we have to finish the domain and range information. Okay, so if you come down here, we're still in need of the domain of f inverse and the range of f. Okay, we know those two quantities have to be equal. Okay, we just found the formula for f inverse of x. Okay, if you look at it, the x plus 1 over x, or if you look at the other version, 1 plus 1 over x, you're dealing with a fraction here. Okay, the bad spot is going to be when the denominator is 0. Okay, so I'm going to come up here. Let me work with this format. Okay, let's do the x plus 1 all over x. Okay, this is a fraction. We're finding its domain. Okay, this is the work to find the domain of f inverse. Okay, this is a fraction. So the bad spot is going to be when the bottom is equal to 0. Okay, so x can't be 0 here. Okay, if you plug in 0 to x plus 1 over x, you're going to be clearly dividing by 0. So the domain of f inverse is going to be all real numbers except x equals 0. Okay, so you can come down here. Okay, we're getting this from the formula for f inverse. The domain of f inverse is going to be all real numbers except for 0. And as soon as we write this down, we know this has to be the same as the range of the original function. Okay, we totally don't have to consult a graph at all. Okay, so we're done with the problem. Okay, we have found the inverse function. Okay, it's a little tricky here because the original function is a fraction. Okay, but we were able to get it, and we were also able to get the domain of f and f inverse and the range of f and f inverse. Okay, let's try another problem like this where the original function is a fraction.